Okay, so today we are going to start section 5 of chapter 8. We're starting to get into planar figures, figures that would lie in a plane. We're talking about triangles and their angles. So pause and make sure you take down this picture, and then we'll talk about what we have here. Okay, so the first word we need to all really understand well is the word vertex. So what do you think a vertex is? Or could you name a vertex in this image that you see here? Anybody name a vertex here? Sabrina? A, good. Okay, A is a vertex. So what do some people want to call vertices in the everyday world? People don't say, oh, you banged into a vertex. They say you banged into a...
Post.
No. What is like a vertex? Say it, Michael. Corner. A corner, right? Okay, this is why if you have a little baby in the family, or when you were a little baby, your parents probably had little bumpers on the corners of their coffee tables and stuff. Anybody have that at your house? Yeah. Yes. Because when little babies are starting to walk, they kind of trip over their feet sometimes and end up splitting open their head on a corner. That happened at my house. Anyway. So vertex is a point where two sides meet. Okay, so a vertex has a V in it. So think of the place where two sides meet. Okay? For a triangle or for any planar figure, it's a polygon that has multiple sides, right? We have these things called altitudes. And in the parentheses, you see H, because in everyday language, we may not use the word altitude. We may use the word that begins with H. Do you know what it is? Riley? What? Height. Good, height. But altitude is the fancy geometry word for height. So the thing about height is there's been one drawn in this triangle. Height always has to be drawing a segment from a vertex to the opposite side, but it must be what? What does this mean here? There has to be a right angle, so it must be perpendicular, okay? The height or the altitude must be perpendicular to the opposite side. And it must leave from a vertex. So I could draw this height differently. I could draw the height, you've seen this before, outside of the figure too, right? I could imagine that I'm leaving this vertex, which is part of the bottom segment, right? And I could go and imagine where would it end, imagine this way. And this is also the height. Do you see that? So you might receive information with the height outside of the figure like that, but as long as they've shown you that it's perpendicular to an opposite side, then you're good. Okay? And do heights always have to be up and down? I mean, when I measure your height, we think of you standing up, don't we? But could I lay you down flat on the ground?
Yes.
And if I measured your height, would I still go from your feet to your head?
Yes.
Or would I go from your belly to your back? No, I would go from your feet to your head, right? Okay. The base is a side that is perpendicular to your altitude. This is really tricky. As I just said, we could choose any side in this triangle here to be a base. Okay, so imagine I could choose side AC, this other side from A to C to be a base, but I would have to travel to the opposite vertex to get the height if that AC is my base. Do you see that? Most of us like to have our figures standing on their base, like it's sitting on its base at the bottom of things. If you like that, then spin your page around and see that the base could be on the bottom if you just spun it around. In geometry, sometimes we have to spin our books around so we can see things better, because we like to see our figures with the bases on the bottom. So feel free to spin your book around when that happens, okay? So everybody, these are two-dimensional figures. So we will talk about perimeter and area. And I need a volunteer. Anybody else? Anybody else? Okay, for you at home, Andrew is volunteering. And so I'm going to ask him to do something in the classroom, because we are today talking about this word here. This word, everyone, is perimeter. So Andrew, I want you to say the word perimeter loudly.
Perimeter.
And keep saying it as you show us the perimeter of the classroom.
Perimeter. Perimeter.
Louder.
Perimeter. Perimeter. Perimeter.
There he goes. He's traveling around the edge, all the way around the outer. Louder.
Perimeter.
Join him.
Perimeter. 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 Perimeter.
All the way back to me. Thank you very much, Andrew. Give him a hand. Good job. And now we will always remember that perimeter is simply a walk around a figure. Okay? A walk around. If we're going to find the perimeter of this figure, how many sides does this figure have? 3, 2, 1, 3 sides. So there is a bit of information in this diagram here that we don't need, right? So we don't use it. We don't just throw numbers together for the sake of it, right? We have to put the right numbers together. And what operation will we use in order to find the perimeter, Izzy? Okay, show me how we multiply here to get the perimeter. I mean, where would you start to find this perimeter? Give me a corner. Let's start here. 39 inches. Okay, so you went this way. Okay, and now where would you go? You go this way. Are you going to multiply these? You're right, you're adding them. We're not multiplying, right? Add it, and then what do you do, Izzy, from there? Go there, so what are we going to do with that? Okay, and then what about this 40 inches here? Do we use that for our perimeter? No, we don't. We don't use it. We just let it sit there. Okay, so everybody find the perimeter. Okay, so we have the perimeter adds up to 130 inches. Now wait, is it just inches or is it inches cubed?
Inches.
Why is it not inches cubed? Why not, Sabrina?
You're not multiplying it?
Good, we're not multiplying it, so it's not inches times inches times inches. This is just like carrying a bag of candy, you know. I have 39 M&M bags, and I have 41 M&M bags, and I have 50 M&M bags, so I've just got M&M bags. I don't cube them. Okay, let's find the area now. So, to find the area, we need a formula. And you should know this from 6th grade. Jimena, what do you know?
Length times width.
Area equals, she's saying length times width. Okay, so I'm backing up because underneath this other definition we have the area of a triangle. And you're right that there is some, I guess, length and width involved, but this is a triangle. So what I like to do is I like to take a paper and make 2 clone triangles. So to do that, I'm folding the paper in half, since there's no video coverage here. And I'm just making 2 clone triangles by cutting 2 together. Okay, does everyone agree we've got 2 clone triangles? Okay? They're clones. It's the same triangle. Okay? So the thing about triangles is you can always take 2 and then you can just kind of rotate and make what when I spin one around? What have I made now? It's not a square. Isn't it a rectangle? Or a parallelogram. I can make a parallelogram. Any 2 triangles can do this. So if I do that here, excuse me, there's a triangle, and I'm going to clone it. If I just spin it around, I will always be able to do this if I take a triangle and its clone and make a parallelogram out of it. Four sides, the two opposite sides are parallel. So how do you find the area of this figure? How do you find the area of a parallelogram? Area equals? Good, base times height. So every triangle is just how much of that rectangle? 1/2. So a triangle then is 1/2 of the parallelogram if we had the entire parallelogram. Okay? So the formula is 1/2 of base times height, and I even like to write it more short by just saying base times height over 2. If we multiply straight across here, the 1 is not really needed. Base times height divided by 2. So please start with the formula. Every time you're asked to find area, write the correct formula for that figure. And this figure is base times height over 2. It's a triangle. So we simply need to find a base and height. And do you see we have a height given a perpendicular altitude? How long is the perpendicular altitude, Abby? Can you see it? This is the perpendicular altitude. Can you see what that number is? 40. Good. So we have the height of 40 inches, and we just need to find the base. There's any side of a triangle could be the base. However, when you find height, it must be perpendicular to the base. So there's only one side here that we can use as base right now, since we're using 40 as height. So together, let's say the length of the base. It is 39. It's the side that's perpendicular to the height. Good. It must be the side that's perpendicular to the height. Okay? And now, as Sabrina told us before, when you're multiplying numbers that have units, what will happen when we have inches times inches? You would square it. And does that make sense with area problems? Should we have inches squared? We should. Yeah, because it's square. So the area is telling us how many little square inches could you put over the top of this triangle? And we simply have to find the numbers now. So what is 40 divided by 2? 20. And now 39 times 2 with a 0 on the end.
78.
780 inches squared. Good. Okay, because there was no addition here, we had 39 times 40 over 2. So we could pull 2 times 20 out of the 40. And we just have factors over factors, so we can reduce. If there was addition up there, you would have to divide both by 2. But there was no addition up there. I know that tricks people, but there wasn't. Okay? Let's find the area of this. Pause, find the area, and come back. Okay, so we will start with the formula. If you didn't put this down, then -2 for you. Okay, you need to start with the formula every time. And the tricky part here is figuring out what is the base and what is the height. So, who can tell us what the base is? Sophia? She thinks 15. Who agrees with her? 15. The problem is, this is the triangle. This is just information that's there to fool you. So that is not part of the triangle. So, do you want to tell me, Sophia, what you think the base is now? 10. Good. 10 feet. And the reason that's there is to give you the distance between the side that is 10 and the opposite vertex. That's why they have this here. The 5 is there to confuse you. And the line is there to show you that this is perpendicular. So what is the height, everyone? 12 feet over 2. And so the answer ends up being 60 feet squared, which is smaller than if you used 5. Right? These are the answers to the GP. Actually, you would have to multiply. And your assignment is here. Have a good weekend.